Hello, everybody. Today we are interviewing Moran Rubinstein. She is an assistant professor at the Department of Human Molecular Genetics and Biochemistry at Tel Aviv University. Hello, Moran. How are you?
Hi, thank you for inviting me.
Oh, it's a pleasure you have time for us. Why did you want to become a researcher?
Always like the puzzles and solving riddles, and I think in science, this is what we do.
And when did you discover this vocation?
I'm not sure. I was always interested in science. I started my bachelor degree in biology, and I started working in the lab during the bachelor. And right from there, it kind of advanced. I think that the tipping point that really suggested that this is what I want to do with my life was when I had to choose whether to go to a postdoctoral studies. And that, of course, entails, in most cases, like in my case, going abroad to working in the lab. For us, it was moving to the US. So it poses some difficulties on a personal life and also on the family. That was the point where I said, yeah, I want to do that, and kind of set my career further from this point on.
And what degree did you complete?
I did my PhD at Tel Aviv University. After that, I went on to complete my postdoctoral studies at the University of Washington in Seattle, the Cathedral Lab. And that was actually my first step into studying Dravet. And in many ways, from there on, it set my career path, really focus on Dravet and try to understand both the neuronal mechanism of Dravet and also try to develop new therapeutic pathways as well as new diagnostic tools.
What values do you think are needed to become a researcher?
So you need to be devoted, you need to be passionate about science, and you need to be a hard worker. And I think maybe one of the most important things is to be optimistic, because in science, many of our experiments fail. So we are encountered with constant failures, and we need to take these failures, learn from them, both from technical failures as well as, more importantly, the negative results that we get, and modify the way that we think to move forward and understand something new from this potentially disappointing experiment.
Is that failure the thing you least like about being a researcher?
No, I actually learned to value these failures now, and I think it's something that makes us grow stronger and constantly keeps us on our toes to try and modify the way that we look at results. In my view, the negative results are as important, or maybe even more important than the positive ones, because it makes us rethink what we know so far. For me, the thing I like the least about research is that we have so much to do that at the end of the day, I never completed everything that I wanted to. There's always more that we can do, and we kind of something that will never catch up. That's also the good thing, because it's never boring. There's always something new to discover. There's always ways to move forward, and that's the plus and minus at the same time.
Why are you researching Dravet syndrome?
It started during my postdoctoral studies at the Cathedral Lab, but the thing that drove me to choose this lab was the fact that I was fascinated, also as part of my PhD, in the way that ion channels contribute to brain activity in healthy brain and also in diseased brain. So during my PhD studies, I was studying the regulation of inward rectifier potassium channel by G protein, focusing on one ion channel, one molecule, and the modulation of these ions. And looking the broader picture of this modulation leads to neuronal function and alteration in the way that we think, the way that we behave. How is it possible that one molecule, one channel can have such a broad impact on the way that we think? Dravet syndrome, I think it's really amazing because it's one voltage-gated sodium channel, one of many, and it has such a huge impact on the way that the brain functions. So moving on to the Cathedral Lab really allowed me this opportunity to try and investigate how these single molecules affect the brain as a whole.
Where did you get your samples from?
So we work on Dravet syndrome mice. Our mouse model was developed by the Spanish Dravet Syndrome Foundation. And I think Dravet syndrome mice are really one of the best animal models for any human disease. Almost perfectly recapitulate all the human symptoms in a mouse in a controlled environment in which we can study and dissect mechanisms and test new therapies and understand, for instance, the connection between seizures and the other comorbidities that are not epilepsy. It's a wonderful tool for a researcher to really understand how these voltage-gated sodium channels, this particular NAV 1.1, affect brain function in normal brains as well as in Dravet brains. And I hope that once we understand that, we can move back to try and correct that.
What projects do you have for this year?
So we have several projects. I think the most exciting one is the gene therapy treatment that we're developing as part of the joint European project, the ERA project, and that's in collaboration with Eric Kramer from CNRS in France and Ruben Hernandez from FEMA. And we have some promising results showing that with the gene therapy into the brain of the mice, we can ameliorate many of the epileptic phenotypes. We're now working on publication of this paper, so hopefully we can say more about that in a few months. The other project that we have is to try and develop early diagnostic tools. In addition to our gene therapy treatment, there are, of course, many other treatments that are being developed, but most of them work best if given early after birth. So it's very important to be able to diagnose Dravet as soon as possible. So there are multiple options for treatment. And using the mice that we know right from the birth, we can check which ones are the Dravet mice, which ones are the healthy mice. We try and highlight markers that can predict the severity of the epilepsy later in life.
What is the importance of a researcher in society?
I think rare diseases offer a unique window to kind of understand the importance of this gene for normal brain function. When we study the diseased brain in comparison to the healthy brain, we can dissect the changes and what is associated with malfunction of the brain that leads eventually to the disease. So I think it really opens a window that otherwise we wouldn't have to understand brain activity more broadly, even beyond the specific disease that we're studying.
And do you think the work of patient organizations is important?
I think it's very important. I think the fact, just as an example, the fact that the Dravet Syndrome Foundation generated this mouse model that we work on, it really enabled us to do this work that otherwise would have been difficult. But in addition to providing practical tools, the patients' organization also provide financial support for research. And personally, I'm funded by both the Spanish Dravet Syndrome Foundation and the American Dravet Foundation. In the American Dravet Foundation, it's in a joint project with Eric Kramer and Ethan Goldberg. But maybe the most important for me as a person is that it gives a voice to the patients, and it kind of gives a feedback of how our work can impact the life of the patients and families and how we give them hope. And that's very important in motivating us and pushing us forward to do our best.
Are you optimistic about the fight against Dravet syndrome?
I actually am. I think the gene therapy treatment that we're developing, as I said, together with Eric Kramer from CNRS in France, and now moving forward also with Ethan Goldberg from UPenn in the United States. And we have some promising results, and the mice are doing better in terms of their epilepsy. We can rescue many of the epileptic phenotypes. It's not perfect yet, but we're moving forward and we keep improving the treatment. And not only our results are promising, there are many other labs that work on gene therapy that already published and presented some promising results. But I think the fact that many people are working together and getting the disease from different angles, I think gives a true hope for the families and patients.
Thank you, Moran.